Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, the lengths of chords, secants, and tangents. Okay. So what this is there's different segments, line segments, that can interact with circles. So sometimes we have these chords that cut across like that. This is a secant because it goes outside, right? And then we have a tangent there because it's going to hit at that G point. It's not actually going to hit the circle twice. So a couple ways we can do it. Three ways we can do this. So look at these two first, and then I'll remind you of what the other last one is. So this is a really common one where we have two chords, and they intersect at point H here. Okay. So what do we know? We know HJ is 22. So down here is 22. HN, so this way, is 33. HM is 11, and we're trying to find HK and figure out what that is up there. So the way that these line up is the two pieces, they're not halves, but the two pieces of each chord, you're going to multiply the length from the intersection point to the edge. So in this case, we'll have like 22 times x, and then we'll multiply these, and that's going to be equal. Okay, so in this case, 11 times 33. All right, so we'll go ahead and just do some quick algebra here, right? So 22 times x is 22x. 11 times 33 should, let's see, 11 squared is 121, so times 3 will give us 363, right? Then we'll just divide by 22. And find out that HK has to be 16.5, and they don't have any units, so that's where we leave that one. Okay. So it's just piece times piece equals piece times piece. Okay. All right, so for this one, these are not chords anymore. This is a secant because it's a chord that extends past the outside of the circle, past the circumference line. And then this one will be a tangent. And normally we can't assume that, but it tells us there's this tangent, a secant, so it's really easy to see that that's secant because it hits twice, so that has to be the tangent by process of elimination. All right, so we know VC here, that just that just that piece is 7.2, and VG, that tangent, is 12. Okay, let me refocus. Okay. It's not working. Let's try manual focus here. Get closer and try it that way. Okay. Well, hopefully you can follow along with the shape. So we have 7.2 on just going from here to here, and this is 12. So the formula for this one is we have a secant. And so the secant's always the little piece, so the part outside, not the little piece, the outside piece, which is usually smaller, but the outside piece times the entire length, so not just this. Okay, so I have VC, I'll write this one out, times VD equals, and since this is a tangent, that's the same length for the outside and the whole length, so VG squared. So when I plug them in, what I know is I know VC is 7.2, and this is a little bit weird. I don't know the whole length here, but I do know that's x, and this is 7.2, so that's 7.2 plus x, if we put those together for the whole length, equals VG, so this guy is 12 squared. All right, so let's try and clean this up the best we can. So if I distribute that 7.2, we end up with 51.84 plus 7.2x equals 144. All right, 12 squared. So go ahead and subtract that over. We get 7.2x equals 144 minus the 51.84 is 92.16. Divide to get CD. So divide by 7.2, and we find out that it is a nice 12.8. So CD is 12.8. Okay. All right. So the only other situation you have is what if instead of VG it cut across like this and we had two secants? All right. That's not a big deal. You just follow the pattern we did here for both secants. So outside times whole equals outside times whole. Okay. So if we put some letters in here, call that A and that B, then it would be VC times VD, just like the first part. That didn't change. But instead of having equal to something squared, because that's just for tangents, it's VA, the outside part, times VB there. So that's how it works.